Yes, good evening student. Today we will discuss about assignment number 9 and we will also solve the problem related to week 9. Okay, so we will wait for a few minutes. Let all join, then we will start. Okay, we should start now. It is 702. It is assignment number 9 of previous semester, which is completed. So I will explain this question and how to answer this type of question and concept behind these questions. Okay, so first question is, the chemical reaction occur during silver tree formation. Okay, silver tree means it is nothing but deposition of silver on copper. Okay, so what will happen? The answer is already yellow line here, highlight by yellow color. Oxidation of copper to Cu plus 2 and reduction Ag plus 2 H. Okay, so two reactions are going on here. Two reactions. First is copper is converting Cu plus 2 electron, and second is Ag plus taking one electron and converting in Ag. Okay, so why? So this reaction is clear. Okay, that why silver is going, because silver gaining one electron and converting in metallic silver. It is silver solid. Okay, so initially it was copper solid, but now it is now it is oxidized and it is now in aqueous form, you can say. Okay, here initially Ag was in aqueous form, but now it is gaining one electron and converting in solid. Okay, so because this solid silver is formed here, okay, Ag is formed here, so this Ag will form will deposited on copper and it will be look like a tree. If you will see magnify image, then it will be look like tree. So that's why it is called as silver tree. Okay, So here we can say that there are two type of reaction. First is copper Cu converting in copper plus. Okay, so this reaction is oxidation reaction. Okay, whereas Ag plus 3 Ag plus is converting in silver solid. Okay, so it is Ag only. Okay, silver. So it is a reduction reaction. Okay, because it is losing electron. Okay, and here it is gaining electron, silver is gaining, so it is reduction, whereas copper is losing electron, so it is oxidation. Okay, so this phenomena will happen when you are putting suppose you are suppose one copper rod is there. Okay, like this is copper rod, and you are filling the solution of silver. Okay, suppose this is the silver nitrate. Okay, and this rod is made of copper. So what will happen here? Copper, because this is solid copper, so copper will be dissolved in solution, and it will make Cu plus 2 ion, whereas AgNO3. So AgNO3 will be dissociate in Ag plus nitrate ion. Okay, so this Ag ion will be deposited here on the surface of this copper, so it will form silver tree. Then again this question rise in our mind, why this reaction is happening, what is the driving force behind this reaction? It is very important, what is the driving force? Okay, why copper is only oxidized? Okay, and why silver is reduced? Okay, so this is depend on its reduction potential. Okay, reduction potential. Okay, so generally we write reduction potential in the form of E. First of all we will write oxidized form. Suppose it is Ag plus. Okay, Ag. So by this way, by writing in this way, it is representing that Ag is converting in Ag. So how much potential it requires? Okay, so if it is spontaneous, means you can say automatic, in simple language we can say automatic, or spontaneous means which is happening without any external force. Okay, so if it is spontaneous, then the value will be positive. Okay, and if this is this reaction is not spontaneous, then it will be negative. Like we can discuss about the zinc. Okay, Zn plus 2, or leave about zinc. We will discuss about copper only. Because we are discussing copper now. Just a minute. Okay, so copper. So Cu, again Cu plus 2 converting in Cu. So what is the reduction potential of copper? So to convert copper plus 2 to copper, it is not spontaneous reaction. Means it will not occur automatically. Okay, you need some force. Means you need some energy. You need to give some external energy so that Cu plus 2 can convert in copper. Okay, that's why reduction potential will be negative. Okay, so here two reactions are going on. First, which has a reduction potential positive potential, whereas another reaction which has negative potential. Okay, obviously then which reaction will be occur? Okay, so the reaction will be occur which required. Okay, means suppose the Cu plus 2 is converting in copper. Okay, so this reaction, first reaction. Okay, so I am talking about this reaction. Okay, so copper converting copper, and it is giving some energy like X energy. Okay, and Ag plus converting in silver, it is also giving you Y energy. Okay, so what will happen here? Copper plus 2, yeah, it's okay. So here to convert, suppose we are discussing in reverse. Okay, so converting copper plus 2 in copper, so it will call as a reduction. Okay, Cu plus 2 in copper, so it will require how much energy? minus x, because it is giving x energy. So if reaction is inverse, okay, in backward side it required minus x energy, okay. Whereas when silver reduce, it will give plus means positive energy, okay, or we can say y energy, okay. So it will be y energy, okay. So I am going to explain here that which reaction will be happen, okay. So in this way we can say when copper converting in copper plus 2, it will give x energy. So x energy is higher than y energy, okay. X energy is higher than y energy. That's why copper will convert in Cu plus to iron, and it will give x energy, which is sufficient, okay, which is sufficient to make Ag plus 2 to Ag, okay. That's why this reaction will be happen, okay. So this is all about this reaction. Just a minute, I think somebody is writing someone. Let's everyone send message. Final exam will be subject. Okay, you can ask this type of question in Google, Google forum. Okay, if you have any question regarding the lectures of week 9 or assignment, then you can ask, okay, because I am not authorized person to answer this question, okay. So I think first question is clear to you. If you have any doubt, you can ask, okay. So simply I explained many more here, but simply we can say when Ag plus T converting in Ag, okay, it will give some energy, okay. In reduction it will give some energy, where when copper plus 2 converting in Cu plus 2, then it will give some energy, okay. So here it is giving some energy like x, okay, where this energy will consume, okay, to convert means we can say copper convert in copper plus 2, okay. So Ag, here Ag will convert, sorry, Ag plus will convert in Ag, okay, just inverse. Here it is oxidation, but here it is reduction, okay. So when oxidation is occur, it will give some energy, okay. So this energy will consume in reduction, okay. I think it is clear to you. Any doubt, you can unmute and ask, okay. So this is the explanation. When a piece of copper is immersed into silver nitrate, okay, piece of we have already discussed this reaction, okay. So copper piece you are immersing in silver nitrate solution, then replacement reaction occur when copper loses electron, okay. So copper loses electron means copper is converting in Cu plus, it is oxidized to Cu plus and Ag ion in the solution gain electron and get reduced to metallic silver. Ag0 means it is a metallic silver, okay. This 0 is representing oxidation state of silver, and deposited on copper, leading to growth of silver crystal known as silver tree, okay. So this is silver tree is nothing but silver crystal which is depositing on copper. The silver nitrate in water dissociate into silver and nitrate ion, okay, obviously. So again we can say this is the copper wire, okay. If you are adding silver nitrate, it will dissociate in Ag plus nitrate, okay. So this is dissociation, okay, and because it is electrolyte, you can say how to call AgNO3, it is a electrolyte, Ag plus and NO3 minus, okay. The silver nitrate dissociation silver nitrate, the silver and copper trade place, so that silver metal takes the place of some copper, okay. Means there is competition, okay, that copper will convert in copper plus 2 or Ag will convert in Ag plus 3, okay. So it is depend on their reduction potential, Okay. So if reduction potential is higher, then reduction potential is lower. Okay. Then oxidation potential will be higher. Okay. So for copper, oxidation potential is higher. You can say it is positive. Okay. So its reduction potential will be negative. Similarly, for silver, oxidation potential is negative. Oxidation, we can say E, oxidation potential for silver. Okay. For silver, oxidation potential is negative, but reduction potential is positive. Okay. Similarly, for copper it is just inverse. Okay. E oxidation is positive, where E reduction is negative. Okay. So the trade place will be there, and finally, while some copper goes into solution, the copper ion change the color of liquid, making it blue. Okay. So now what is happening? Initially it was silver nitrate. Okay, but silver is deposing at Ag. So copper, which is copper which is in solid form, converting in copper plus 2. Okay. So this copper plus 2 will be responsible for color change. Why color will be changed? This Cu plus 2 will react with nitrate ion, which is already present in solution. Okay. And it will make what? It will make copper nitrate, CuNO3. Obviously, it will make copper nitrate and it will give blue color. Okay. So color of solution also will be changed due to this reaction. Okay, any doubt in this question? No? Let me see. So now question number 2. The correct statement among the following are. Okay, we need to find out the correct statement. In galvanic cell, electrical energy consumed, while in electrolytic cell, electric energy is released. Okay, so it is not correct. Okay, because galvanic cell means what? General cell like lead battery and whatever. Okay, lead acid battery, and generally you are using galvanic cell, which what? Electric energy consumed. No, it will give electrical energy. Okay, chemical energy will convert in electrical energy. While in electrolytic cell what will happen? Electrolytic cell, electric energy will be used, and it will be used to dissociate any electrolyte. Okay, so electric energy will be released, so it is wrong. Okay, so first statement is wrong, obviously. Okay, second question is, in electrolytic cell, electrons flow from anode to cathode through the external circuit. Okay, so to discuss about this option, we will just discuss about the electrolytic cell. Okay, suppose this is the beaker. Okay, and we are putting 2 electrodes, and it is connected from battery, because it is electrolytic. Na means you are using electricity to break something. Okay, light means you are breaking something. Okay, so suppose we are adding one battery. Okay, let me write this is positive and this is negative. Okay, and it is filled simple water. Okay, water is there. So what will happen? What will happen when you applied current? Water will be dissociated H plus and OH minus ion. Obviously, then due to charge, hydroxyl ion will move toward positive ion, whereas hydrogen ion will move toward negative ion. Okay, so hydrogen ion will come here and it will gain electron, from this battery, okay, because it is negative terminal, so it will get electron and it will convert in hydrogen gas, okay. You can say 2 hydrogen and 2 electron, okay. So finally it will get hydrogen gas will be released from negative terminal, okay. And here in positive terminal, OH ion will be moved toward here, okay. It will lose electron and make H2O plus oxygen, okay. So oxygen will be released here at positive electrode and hydrogen will be released at negative, okay. So this is all over about the electrolytic cell, okay. So what will be happen here? So here actually this oxygen OH minus it is, and here it is 2H, so hydrogen, okay. So what is written here? In electrolytic cell, electron flow from anode to the cathode through the external circuit, okay. No, it is not wrong, because electron is flowing from current is flowing from battery, okay, and it is not from anode to cathode, okay. So this is also wrong option, okay. So cathode is what? Cathode is what? Where you can say reduction is happening, okay. So where reduction is happening here? We can say OH minus losing electron, so oxidation is happening. Here the hydrogen is gaining 2 electron, so here reduction is happening. So we can say this is the cathode and this is the anode, okay. Then option number C. So 2 options are wrong. We have discussed about that. Okay. Then option number C. In a galvanic cell, electron flow from the cathode to the anode through the external circuit. Okay. So let me discuss about this thing only. Okay. Suppose we are making one cell which is made by zinc and let's say copper, okay. So what is happening here? So suppose this electrode is made of zinc, okay, and another this electrode is made of copper, okay, and it is connected by salt bridge like that, okay. And suppose we can connect it by wire like that, okay. Now it is electrolyte. So this electrolyte is zinc sulfate and this electrolyte is copper sulfate, okay. So what will happen here? Here zinc will convert Zn plus will convert Zn plus 2, okay, plus 2 electron. So this reaction is happening here, okay. It is oxidation reaction only, whereas at this place in copper electrode, you can say copper sulfate. So from copper sulfate this Cu plus 2 ion will become, it will gain 2 electron and convert in copper metal, okay. Sorry. So what is happening here? Here zinc is converting in Zn plus 2, where here Cu plus 2 in converting in copper, okay. So this is nothing but reduction, and it is oxidation, okay. So it will call as a cathode because reduction is happening. So it is cathode and it is anode, okay. So this is all about galvanic cell. So in a galvanic cell, electron flow from the cathode to the anode. So electron is not flowing from cathode to anode, electron is flowing from anode to cathode, okay, from here to here. This is the flow of electron, because here Zn converting is Zn plus 2 and it is creating 2 electron. So these 2 electron will be created here, so it will be conveyed from this wire, okay, and finally it will be reached here. So from anode to cathode, okay. So not cathode to anode. So this option is also incorrect, okay. If you are not able to understand or you have any doubt, you can message me or you can ask directly by unmuting your microphone, okay. Then finally D option, the cathode in galvanic cell is converted to anode when it is operated electrolytic cell. Obviously, this is right option. Okay, because when any galvanic cell converted in electrolytic cell, means what you are doing, you are just providing energy, electricity from the outer source. Okay, minus plus like that. So what will happen, the terminal will be changed. Okay, cathode will be changed in anode, anode will be converted in cathode. That's why the option D is correct. Okay, so this is all about question number 2. Any doubt? Question number 2. I think no doubt. Let me explain this question again. A galvanic cell convert chemical energy into electrical energy. Okay, galvanic cell means generally we are using different type of cell. It is primary or secondary. So what is the purpose of this cell is, they convert chemical energy into electrical energy. An electrolyte cell convert electrical energy into chemical energy. Okay, just opposite what you are doing. You are providing electrical energy and it is doing some chemical job, means it is separating electric species like water. Okay, from H2O it is separating H plus and OH minus. Okay, then it will, hydrogen gas will be there and oxygen gas will be there, like that. Okay, so this is the job of electrolytic cell. In a galvanic cell, anode is negative electrode. Okay, anode is negative electrode. So which one is anode? In our case it was copper. Okay, so no, not copper, Zn. Okay, Zn is converting Zn plus 2 and it is giving 2 electron. So this is the, it is called anode, which we just discussed. Okay, so in galvanic cell, anode is the negative electrode, because when oxidation occurs, electrons are left behind the electrode. Okay, so electrons are left, so these electrons are leaving here. Okay, this electron then flow through external circuit. Okay, then suppose this is the zinc electrode, so here zinc will be converted in Zn plus 2 and it will give 2 electron. So this 2 electron will convey from this this wire, then this wire, and finally it will move to the copper. Okay, this is the cathode, this is the anode and this is the cathode. So electrons are flowing like that. Okay, so this electron then flow the external circuit to the cathode. Okay, while in electrolysis, an electric current, okay, in electrolysis what will happen, electric current drives electron flow in opposite direction and the anode is positive and electron. Okay, so anode is positive in this case. Okay, so suppose this is the, this reaction will be happen where, okay, H plus, so you need to connect this negative and this positive, like that. Okay, this will be 2 terminal. So here, because it is negative and it is positive, okay, so negative hydrogen ion will become and it will convert in hydrogen gas and negative electron, whereas OH minus attract toward positive electrode and it will make oxygen here. Okay, so where is reaction is happening, so anode is the positive electrode. Okay, so it is a anode. Okay, it is cathode. Why it is cathode? Because reduction is happening here. Okay, reduction is happening here at cathode. Okay, but it is positive electrode. Okay, but whereas it is another is anode is positive electrode. Okay, so this is the anode and it is a positive electrode, whereas cathode is negative electrode. Okay, so it is clear, I think. Okay, clear why it is anode and why it is cathode. Cathode always when reduction is happening. Okay, so this is cathode and it is connected to negative terminal, whereas anode is what, where oxidation is oxidation is happening here. Okay, because it is leaving electron na? Okay, that's why it is anode. Okay, and anode is positive here in this case. Let me see if anyone writing something or okay. So this is clear. I think second question is clear. Third question. The Ca+2 ion concentration in solution can be determined with the help of, okay, you need to analyze Ca+2 ion, okay, Ca+2 concentration. So glass electrode will not use, because glass electrode is used for hydrogen ion, sodium ion and potassium ion, okay. So for calcium, liquid membrane electrode is used, okay. For calcium, liquid membrane electrode is used. It is a membrane which allow to pass calcium ion, okay, and according to that, potential will be generated and which will be used to measure the concentration of calcium ion in your analyte solution, okay. So obviously this is both glass and electrode not correct, and this is also not correct, okay. So B is right answer, okay. So let me explain this question again. One of the most famous liquid membrane electrode has been used for calcium determination, okay. So liquid membrane is right answer. Initially, researchers attempt to use glass membrane electrode, okay, glass membrane electrode which is used for sodium and potassium ion. It is also tried to use for calcium ion, which had been successfully for monovalent cation, okay. So glass membrane electrode is suitable for what? It is suitable for monovalent cation. What is meaning of monovalent? Means single, like H plus, Na plus. These are the monovalent, okay. Only one positive ion is there, so it is suitable for monovalent cation. But we are discussing about bivalent cation, okay. It is Ca+2, no? So it is a bivalent cation. To detect bivalent cation such as Ca+2, when this was determined to be unfeasible, okay, glass electrode is not feasible for bivalent cation. That's why liquid membrane were developed, okay. That's why liquid membrane was developed. This electrode works by an ion exchange process, okay. How it will be there? It will be ion exchange. Exchange means you are providing one ion and taking one ion, okay. Your system is doing like that. So this electrode work by an ion exchange process. The cation exchanger is an aliphatic diester of phosphoric acid, okay. So what is phosphoric acid is that? Just a minute. Okay, so phosphoric acid means this is the phosphoric acid, H3PO4, okay. Now cation exchanger is aliphatic diester of phosphoric acid, okay. Diester, okay. It is two ester group is attached here. Just a minute. So it will be okay. Two group will be attached like that, okay. Okay, so this is the structure of this cation, okay. Means one negative ion will be there, okay. Total 4 oxygen and 2 group like that, okay. So it is a diester of phosphoric acid, where R group, this R group is aliphatic hydrocarbon. Aliphatic means chain, okay, like that. Aliphatic hydrocarbon chain containing 8 to 16 carbon, okay. So this chain length is about 8 to 16 carbon. The phosphate group can be protonated, but because it is a negative charge, na, so it can be protonated. So it will be attract proton and it can be protonated. but has strong affinity for calcium. Okay, but this molecule has strong affinity toward Ca plus 2. Okay, compared to hydrogen ion, it has strong affinity toward calcium plus 2 ion. The cation exchanger is dissolved in an organic solvent. Okay, so this what is cation exchanger? This one. Okay, this biester, this is biester derivative of phosphoric acid. Okay, so diester derivative of phosphoric acid will be dissolved in organic solvent and held in porous compartment between the analyte solution and internal reference calcium chloride solution. Okay, so internally calcium chloride solution will be there. Okay, and this this diester phosphoric acid will be dissolved in organic solvent, and finally it will be filled in porous compartment. Okay, so this whole assembly will be known as liquid membrane electrode, and it is used for calcium ion estimation. Okay. Okay, so I think it is clear. Then question number 4. The glass electrode can be used for direct potentiometric measurement. Just a minute, who is there? Okay, so question number 4 is, the glass electrode can be used for direct potentiometric measurement of. Okay, so glass electrode we have already discussed, it can be measured for H plus ion, Na plus ion and Ag plus. Okay, so obviously these two options, ions are given here. Okay, so it will use for that. Ca plus 2 we just discussed. Okay, it will use liquid membrane. Okay, leave all other case because it is ammonium and magnesium 2 plus ion. It is also hydrogen, but magnesium ion is there. Okay, so these all other options are incorrect. So first option is correct answer of this question. Okay, so glass electrode are made of ion exchange type of glass membrane. Okay, so glass electrode is also made by ion exchange type of glass membrane. Okay, it is also, the working principle is same, it will also ion exchange type and possess good selectivity, particularly for silver ion, sodium ion, hydrogen ion. Okay, so it has particular selectivity of toward these three ions only. Okay, so means principle is same for the liquid membrane and this glass membrane. Okay, but particular ion selectivity is different. Okay, that's why here in glass electrode we can accurately measure this ion only, which are silver, sodium and hydrogen ion. Okay, then question number 5. Among the following, the correct statement about the lead acid storage batteries. Okay, lead acid storage battery is very common. Okay, for secondary cell we can say. Okay, in our bike, car and scooter, whatever. Okay, so generally lead acid storage battery is used. Okay, so we need to find out some statement regarding this lead acid battery. It is an example of series of irreversible cell. Irreversible means if you used battery once, it is not able to charge, but we know that lead acid battery can be charged again. Okay, that's why charging and discharging is continuously going on. Okay, so this option is incorrect. It can act as a both galvanic and electrolytic cell. Yeah, it is right answer. Okay, so galvanic cell when it is giving power or current. Okay, when it will provide current, it is work as a galvanic cell, and when you put battery on charge, it will work as electrolytic cell. Okay, so these both phenomena will be happen here. So this option is correct. We will explain a little bit more about the chemical reaction and all about this lead acid storage battery. Option C, it is an example of combination of reversible and irreversible cell. No, it is completely reversible. Okay, so it is also not correct, and obviously this option is not correct. Okay, so option B is correct. Let me discuss something more about that. Okay, so this is the explanation of this question. So it is an example of series of reversible cell. Okay, so what will happen in your lead acid battery? Okay, so suppose this is one battery like that. Okay, okay, so it is, these batteries are connected like that. Minus plus minus plus minus plus minus. Okay, so your one single battery can give around 2 volt. Okay, but generally we need more energy or more voltage. Okay, so what we do, we just connect cell in series mode. Okay, so suppose here one battery is 2 volt. Okay, so we connected here 4 battery, so it will give you 8 volt. Okay, so these batteries will give you 8 volt. Okay, so this is the series of reversible cell, and each cell is reversible. Okay, each cell is reversible and these cells are connected in series. Okay, so it is example of series of reversible cell. It can act as both galvanic and electrolytic cell. Okay, how it is that? So we will okay, so we will discuss about the reaction while discharging and charging. Okay, so what is the meaning of discharge? When you take energy. Taking energy means, suppose this is your battery. Just a minute. Okay, suppose this is the battery, minus plus. Okay, and you are connecting your battery with some load. Load means, suppose this is the bulb. Okay, and this bulb is glowing means what? You connect this battery with this bulb. So energy is consuming. Okay, so your battery is giving energy to this bulb. Okay, that's why your bulb is glowing. So what will happen? At that time discharging will be there. Okay, this bulb will not continuously glow. After some time it will be dim and finally it will be off. Okay, finally it will be off because all the energy in this cell is consumed by this bulb. Okay, so what changes are occurring in this battery? Okay, so we can understand the change by this chemical reaction or in discharge process. Okay, so in discharge process, lead, okay, lead and this is the hydrosulfide ion. Okay, minus 2 electron. Okay, it will lose 2 electron and it will dissolve. It will convert in lead plus 2 and SO4 minus 2 plus hydrogen ion. Okay, so this lead plus 2 and SO4 can combine and make lead sulfate. Again lead sulfate can convert in lead plus 2 and sulfate. So this is the reversible reaction. Okay, finally you can say it will be okay, so lead sulfate is forming when discharge process is going on. Okay, so when all lead is consumed and converted in lead sulfate, your battery will be totally discharged. Okay, at that time it will be work as galvanizing cell. Okay, at that time it will be work as galvanizing cell. Okay, but at the charge process, this lead sulfate, okay, which convert in lead plus 2 and sulfate ion, okay, it will gain 2 electron. This 2 electron is coming from where? It is coming from external battery. Okay, so external energy source which you are applying to charge this battery. Okay, so these 2 electrons are coming from outer source. Okay, so this when this 2 electron will come, this lead plus 2 again convert in lead. Okay, and SO4 minus. So this both are reactant of this one. Okay, so when you charge it, again lead sulfate convert in lead and HSO4 minus, which is the which is the reactant of this reaction, discharging reaction. So you can say this is the charging. Okay, so when lead is made, your battery is fully charged, whereas when lead sulfate is formed, your battery is going to discharge. Okay, so this process will be continued. That's why it is a reversible process. Okay, I think it is clear. Any doubt? Here you can ask. No doubt in this question? Okay. Then question number 6. The standard electrode potential of a chemical species is its electrode potential when the activity of all reactant and product in the solution is unity. Okay, why unity? Because we are discussing about standard electrode potential. Okay, so to measure electrode standard electrode potential, we take 1 m concentration. Okay, 25 degree centigrade temperature, activity should be also 1. Okay, so at this condition, at 1 atmospheric pressure, like that. Okay, at that condition we measure potential and we explain this potential as standard electrode potential. Okay, so it will be 1 only. Okay, so this is the explanation of this question. The potential associated with each electrode in the electrode potential when the two chemical species at two electrode have equal concentration of unity. Okay, it should be equal and it should be unity. For gases, it should be at 1 atmospheric pressure, and the reaction between these species is carried out as 298 means, okay, 273 equal to 0. Okay, so it will be obviously 25 degrees centigrade. Okay, then the potential of each electrode is known as standard electrode potential. Okay, then question number 7. Here you can see this reaction Fe plus 3 getting 1 electron and converting in Fe plus 2. Okay, so what is this reaction is? It is gaining electron, so it is reduction reaction. Okay, so the correct Nernst equation for the above reaction is, okay, so if you know about the reaction, okay, so it is a E0 minus 0.0592 logarithm of, okay, concentration of product. Okay, so concentration of product is Fe plus 2, so it will be Fe plus 2. Concentration of, sometime we use at activity. Okay, and concentration of reactant, so it is Fe plus 2. Okay, so this is the right answer. Okay, so you can write Nernst equation like that. Okay, this is derived from RT upon NF. Okay, R is gas constant, T is temperature, N is electrons, okay, mole of electron which are taking part in reaction. Then F is Faraday, which is 96,480. Okay, so if you are putting this equation, these values in the, these all are constant only. Okay, N value you can find out from the reaction. Okay, so here it will be 1 only because only 1 electron is taking part. Okay, so it is also 1, so RT upon F only. Okay, so these all are, means temperature we know at room temperature. Okay, so R gas constant and it is Faraday constant, so if you put value you will get this. Okay, and finally this is the Nernst equation of this question. Okay, this is the explanation. Nernst equation for the above reaction is where n is number of electron transferred, so only one electron is transferred. Okay, this is the coulomb. Okay, this is the charge only. What is the coulomb means? It is charge. How much charge? It is a charge of 1 mole electron. Okay, 1 mole electron charge. And what is the meaning of 1 mole electron? It is equal to 6.023 into 10 power 23 electrons. Okay, these are the number of electrons. Okay, so if you are going to count charge on this number of electron, which is equal to Avogadro number, okay, then it will be equal to 96,408. Okay, then R is gas constant. I think you know about this value, 8.314 joule per Kelvin per mole. Okay, and temperature is 25 degree on centigrade only. Putting all the value, converting the logarithm function, we get this value. This is the concentration of product, whereas Fe plus 3 is concentration of reagent. Okay. Okay, then question number 8. When the direction of current is reversed in case of a irreversible cell. Okay, irreversible cell means if you are going to make A to B, you will not able to make B to A. Okay, if you are going to convert A to B, but you are not able to convert again B to A, so it is an irreversible reaction. Okay, so what will happen? Suppose suppose this is the cell. Okay, where you are putting some potential. Okay, this is the battery. Okay, and some reaction is going on. Here what is going on? A is converting in B. Okay, but what you are doing now, you are changing the terminal. Okay, so now you are converting this is as a plus and this is a negative. Okay, so now you change terminal. Now it will be B because it is positive and it is negative, so it is small. Okay, so but B is not able to convert in A, so it will convert in some other species like C. Okay, when you apply reverse potential, it will be converting C. Okay, so that's why when the direction of current is reversed in case of irreversible cell, how different half reaction will be occur at the electrode. Okay, so suppose this is the half reaction, A is converting in B. Okay, but because it is irreversible, so when you apply reverse current, this half reaction will not reverse. Okay, this is not possible. Okay, but some different product can be generated. Okay, like B to C can be generated. Okay, but A cannot be generated. So a different half cell reaction will occur. Okay, so this is right answer. A different half cell reaction will be occurred at the electron. Okay, so this is the right answer. Okay, obviously same half reaction will not occur. The reaction of cell will be reversed. No. Okay, it is also. So first is right answer, and I think it is very well explained. Okay, so this is the explanation of this question. In a reversible cell, reversing the current reverse the cell reaction. Okay, this case is for reversible cell. Okay, so here A to B, but when you change the direction, it will be B to A. Okay, so it is for reversible case. But in an irreversible cell, reversing the current cause different half reaction. Okay, here if you change the current, it will not form A, it will form C, different way. Okay, one or both the electrode reversible cell. In which the direction of the electrochemical reaction is reversed when the direction of electron flow is changed in a irreversible cell. Changing the direction of current cause entirely different half reaction to occur at one or both electrodes. The lead acid battery, we have already discussed, it is reversible. So the lead acid battery storage battery is automobile in common example of series of reversible cell. When an external charger or generator charge the battery, its cells are electrolytic. Okay, when it is charging it is electrolytic, but when it is used to operate headlight means what? You are taking energy from it, it is discharging, your cell is getting discharging. Okay, your cell is getting discharged. So when it is used to operate headlight, radio, whatever energy source, okay, it will behave as a cell, as a galvanized cell. Okay. Then question number 9. The electrode potential of a saturated calomel electrode against the SH. Okay. So it is a saturated hydrogen electrode. Okay. So its potential is 0 only, 0.0 volt. Okay. So with respect to standard hydrogen electrode, the electrode of saturated calomel electrode. Okay. So it is a 2.44 only, and you need to memorize it. There is no concept. Okay, you can calculate by Nernst equation if some data are given. Okay, but here you need to memorize this hydrogen electrode potential, then calomel standard potential, like that. Okay, so the electrode potential of saturated calomel electrode against SC is 0.244 volt, and it is depend on concentration of fluoride ion. It is like silver fluoride electrode. Okay, so it is calomel electrode. Calomel means what? HgCl2. Okay, so HgCl2, sorry, Hg2Cl2 is calomel. Okay, so when it is converting Hg plus 2, what's fluoride minus 1? Okay, so it is solid. So if you write Nernst equation, okay, because it is solid, so the Nernst equation will be depend on this chloride ion. Okay, so that's why it is similar to silver chloride electrode. It is also depend on chloride ion. It is a 2.80 in 1m KCl, and it is for 2.44 in standard KCl in saturated KCl. Okay, so what you are doing? It is 1m KCl concentration only, and it is saturated. So you are increasing the concentration of KCl. Okay, so its potential is decreasing. Okay, like that. So it is depend on what? It is depend on. So you are changing KCl concentration. So means what? You are also changing the concentration of Cl minus. Okay, because K plus Cl, it will be dissociated in Ka plus Cl minus 1. So you are also changing the concentration of Cl minus. Okay, so you can abbreviation SC is what? It is a saturated calomel electrode. Okay, so you need to memorize, because sometimes you will see only this notification or this abbreviation, so you should know about the full form of this okay. Finally, we are going to discuss question number 10. At high hydrogen concentration, the formal potential for Fe plus 3 to Fe CN4 system will be greater than standard redox potential value of FeCN. Okay, so what will be happen at high hydrogen concentration? What will be happen if it is there? Hydrogen concentration means more hydrogen ion, so it will make so this is what here Fe is in plus 3 form. Okay, sorry, it will be not it will be negative. Just a minute. Okay, it is minus 3. Okay, how it is formed? Initially it is Fe plus 3. When it reacts with 6, just a minute, this is my bad. Okay, so it is FeCN. So it is making bond with 6 here ion. Okay, so here 6 negative charge, here 3 positive charge. So 3 will be cancelled with 3 negative, but still 3 charge will be remain. Okay, so it is made from Fe plus 2 ion, Fe plus 3 ion. Whereas if Fe plus 2 make bond with 6 CN minus ion, so it will make what? Fe 2 positive ion consumed by 2 negative ion, so it will make still 4 negative ion will be remain. Okay, so these are the two complex made by ferrous and ferric ion. Okay, so now if hydrogen ion is there, okay, so these are the negative species, either it is ferrous or ferric, both are, it is ferric. Okay, it is ferric, this is the ferric, where it is a ferrous. Okay, so both are negative species, so it will make bond with hydrogen ion. Okay, so there are 4 hydrogen, so you can say 4H will be attached here, and here 3H can be attached. Okay, so this type of species will be formed. Okay, and what question is asking, the higher H plus concentration, the formal potential of system will be. Okay, so greater than the standard reduction potential value of, greater than the standard redox potential value of. Why it is greater? Okay, because Fe3 is converting in Fe plus 2, but when hydrogen ion will be attached, it has more tendency to attach with ferric. Okay, hydrogen ion has more tendency to attach with ferric. So if you write Nernst equation for this electrode potential, it will be E0 minus 0.0593 upon, because here only one electron is transferring, so 1 logarithm of concentration of product. Okay, so what is product here? Ferrous. Okay, because here to here na, so it is ferric, it is ferrous. Okay, okay, so it will be like that as for FeCN 6 divided by S3 FeCN 6 minus 3. Okay, because iron has more hydrogen has more tendency to attach with ferric ion, so this ratio will be less than 1. Okay, so this ratio will be less than 1. Okay, so finally you will get less okay, so finally you will this ratio will be less than 1, so finally you will find greater than the standard redox potential value of, because if you solve this thing, you will get greater potential, okay, for this system. Okay, it is also explained in the next slide. We will discuss. Okay, here. So at high hydrogen concentration, both the complex anion get protonated to form, this is ferric species and this is ferrous species. So both are protonated, which weak acid, okay, then the former, hence ratio of efficient 4 minus and efficient 6 minus 3 will be less than 1. Okay, so now the ratio will be less than 1. Why this ratio will be also less than 1? Because here this species will be more. Okay, so this species will be more, and so the this ratio will be efficient 4 minus efficient will be less. Okay, and according to Nash equation, observed potential will be higher. Okay, so it is a 0.72, where E0 is only 0.36. Okay, so this is all about this question. Can you repeat? Yeah, because hydrogen ion has more tendency to attach with this species. Okay, that's why its concentration will be high. Okay, so this is all about assignment of question number 8. Sorry, this assignment number 9. Okay, so now if you have any doubt, you can ask regarding this assignment or regarding your lectures of week 9. Any doubt? If you have if you do not have doubt, then we will discuss some concept about this electrochemical cell and Nernst equation, like that. Okay, so I will discuss the, because we have more time, so let me just. Are you able to see redox reaction? Are you able to see or not? Hello? Are you able to see redox reaction? Yeah. Okay. So we will start from here. Okay. I will take 5-minute break. Then I will continue. Okay. So you can also take for 5 minutes. Then we will start. Clear? Yeah. Okay, so we should start now. Okay, so to discuss about the electrochemical cell, we should aware about what is the redox reaction, because it is nothing but the part of you can say redox reaction only. Okay, so in electrochemical cell, like that, a redox reaction is the reaction between zinc and copper. Okay, so what is happening here? Zinc and copper salt occurring in a battery. Okay, so zinc and copper, zinc is converting in Zn plus 2 oxidation, whereas copper is reduct. Where copper is converting in copper, so it is reduction. Okay, so oxidation and reduction both are happening, and it is making a cell. So this should be known, should be clear that in electrochemical cell there are reduction and oxidation. Two reactions are there. Okay, so now we can separate that one reaction like oxidation reaction and reduction reaction. It is called as a half cell reaction. Okay, how it is that we will discuss next. First of all, we will discuss the structure of electrochemical cell, or it is also known as a galvanic cell. So here the device in which electrical energy is produced from chemical reaction. Okay, so here what is happening in electrochemical cell? So electrical energy is generating from chemical reaction are called electrochemical cell or galvanic cell or voltaic cell also. In this cell, oxidation and reduction reaction occur. Okay, I have already told you that both reaction will be occur. That's why it is called redox reaction. Okay, separate container called half cell. Okay, so oxidation and reduction occur in separate container, first and second container, and it is called as a half cell reaction. Okay, so the redox reaction is spontaneous. Spontaneous means it will occur automatically. You need not to provide any external driving force. Okay, it will be occur spontaneously. Okay, so here if we discuss about this cell, this is the first beaker, this is the second beaker, or first container and second container. Here it is first electrode which is made of zinc, and it is immersed in zinc sulfide. Okay, or we can say it is dipped in zinc sulfide. It is not immersed, dipped. Okay, because only half electrode is dipped here. Where in second second container, copper electrode is dipped in copper sulfate solution. Okay, so zinc sulfate here make 2 ion Zn plus 2 and SO4 minus ion. So I need to write here. Okay, similarly here it is copper sulfate, so it will make Cu plus 2 and SO4 minus 2 ion. Okay, so here copper sulfate is used as an electrolyte, whereas in first container zinc sulfate is used as an electrolyte. Okay, so zinc will convert in Zn plus 2 plus it will give 2 electrons. Okay, so this question should be rise in your mind that here copper plus 2 taking 2 electron and converting in copper metal. Okay, so why it is happening so? Why zinc is losing electron, but here it is gaining electron, copper is gaining electron. Okay, so it is, and I already told you that this cell is spontaneous, means you are not providing any external driving force. Okay, so why this reaction is happening? So we can say when okay, so we are telling that zinc is converting in Zn plus 2, this reaction is spontaneous. Similarly, copper taking 2 electron and converting in copper. Okay, so means how it is possible? It is possible only when zinc converting in Zn plus, it is giving X energy. Okay, if this reaction is giving X energy, so this energy is sufficient to convert Cu plus 2 in Cu. Okay, then only this reaction will be occur. Okay, or we can say the reduction potential, now we will discuss about the reduction potential. Okay, so reduction potential means copper plus 2 converting in copper. Okay, so reduction potential of copper should be less than reduction potential of, or we can say reduction potential of zinc will be negative. Okay, because it is already it is oxidizing here, na, so its reduction potential should be negative. Okay, but it should be less negative compared to copper. Okay, it should be less negative to copper. That's why copper can convert in copper, copper plus 2 converting in copper. Okay, okay, but Zn plus 2 to Zn required more energy compared to convert copper plus 2 to copper. This is only I need to say. Okay, so it required more energy to convert Zn plus 2 to Zn compared to copper plus 2 copper. Okay. So the setup of Daniell cell, how it is set up, what are the required specification for setup of this Daniell cell is, the arrangement consists of two beaker, one which contain 1 mole zinc sulfate and another 1 mole of copper sulfate. Then zinc rod is dipped in zinc sulfate while copper rod is dipped in copper sulfate. Okay, this electrode behave as a terminal to hold the electrode. The two electrodes are connected via wires. Okay, now again one new term is salt bridge. Salt bridge is placed between the two beakers. This provides a path for the movement of ion from the beaker to the another beaker to maintain electrical neutrality. Electrical neutrality means we do not make any charge. Okay, so how it is possible? Like, let me. Okay, just. Okay, so in this reaction we discussed that here here this zinc electrode, so here Zn converting in Zn plus 2. Okay, so Zn plus 2 ion coming in electrolyte. Okay, whereas at the cathode Cu plus 2 converting in copper, so it is depositing on the copper surface. Cathode, it is cathode only. Okay, so it is depositing on cathode. So sulfate, okay, so this copper plus 2 ion coming from where? It is coming from copper sulfate only. Okay, so after some time the concentration of sulfate ion will be increased in the solution, whereas here the Zn plus 2 ion concentration will be increased. Okay, so charge balance will be disturbed. Okay, that's why to maintain electrical neutrality we will use salt bridge. Okay, so what will happen, because it is zinc Zn plus 2 converting here, so salt bridge is made for KCl. Okay, so KCl, it is made for potassium ion and chloride ion. So chloride ion will be moved this side, okay, and it will be neutralized Zn plus 2, whereas potassium ion will be come this side and it will neutralize sulfur ion. Okay, so overall charge neutrality will be maintained. Okay, so this is the working principle of salt bridge. Okay, and it is used to maintain electrical neutrality. Okay, these all things we have discussed, so I will just move forward. Okay, always remember for electrochemical cell, oxidation occur at anode and reduction occur at cathode. That's why copper plus 2 converting in copper. So it is a reduction and it will be occur at cathode, and Zn converting in Zn plus 2. So it is oxidation and it is occur at anode. Okay, so keep this thing in your mind. Okay, it will be very helpful in future. Salt bridge we have already discussed. It is not made only KCl. Sometimes it cannot be ammonium nitrate. Okay, so different type of salts are used to make salt bridge. Okay, this is not relevant. Now it is also very much important for you how we can represent electrochemical cell. Okay, generally if you will see, electrochemical cell is represented in this way, but you need to read, you need to know how to read this type of representation. Okay, so Zn2 means this is only cell which we have discussed. Okay, so this is Zn, this is copper. Okay, and these are the two beaker. Okay, and it is connected by salt. This is only cell. So and here it is zinc sulfate is formed, and here copper sulfate is formed, which we have already discussed. So I am just making a rough diagram. Okay, so zinc is directly contact with Zn plus 2 because Zn plus 2 means what? Zinc sulfate. So it is directly connect. So it is shown by a vertical line, this vertical line. Okay, and so zinc electrode, this is representing electrode which is connected to zinc sulfate Zn plus 2 ion, and this 1m is representing concentration of this electrolyte. Okay, so concentration of this electrolyte is 1m. Then these are the two vertical lines which are representing salt bridge. Okay, which is representing salt bridge. Okay, so these two cells are connected with salt bridge. Now this is the first half cell up to here. This is the first half cell. Then this is the second half cell. So in second half cell what is happening? Copper plus 2 is converting copper. So we write copper plus 2 first. Okay, here we write zinc first. Okay, because zinc is converting in Zn plus 2. It is a oxidation reaction. Because but here it is reduction reaction and it is cathode. So copper plus 2 will be written first. So Cu plus 2, which Cu plus 2 is representing copper sulfate, which has 1m solution, 1m concentration, which is converting in copper. Okay, so they are directly contact. So it is represented again by vertical line. Okay, so like that you can represent any electrochemical cell, and it is also help to read any chemical cell by this thing. Okay, so there are some rules to write this half cell, which are by convention the electrode on which oxidation occur. Okay, oxidation occur at what? Anode. So it is represented in left hand side. Always oxidation reaction will be written at left hand side. Okay, and another electrode on which reduction is occurred in right hand side. So this is the right hand side. Okay, it is clear. Okay, which reaction, which half reaction will be written in left hand side and which half reaction will written in right hand side. So first is clear. Then the electrode on the left hand side is written by writing the symbol of metal or the gas first, followed by symbol of ion. Okay, why it is? Because reaction is happening like that, na? Because Zn is converting in by Zn plus 2. So if you write like that, Zn like Zn plus 2, so it will be very easy to interpret also. Means zinc is converting in Zn plus 2. So we'll use in this one. Whereas the electrode on right hand side is written first the ion. Okay, why we are writing ion? Because ion is converting in metal. Okay, so we are writing ion first. Okay, and with concentration also. So what is concentration you can represent here. So it will also give you information that which concentration you are using. Okay. Then fourth point is single vertical line. Single vertical line means this line represent the phase boundary. Phase boundary means zinc and zinc sulfate, so it is represented by single. Okay, phase boundary of the electrode, which are boundary between metal and electrolyte solution. Double vertical line, this double vertical line represent the electrolyte connected by salt bridge. Okay, so it is a representation of salt bridge. Okay, so these are some memory aids. Okay, so left side anode, oxidation and negative, right side cathode, reduction and positive. Okay, so generally you write anode first, because A come first in alphabet also. So anode first, then cathode. Okay, so this type anode and this type cathode. Then left right, like that you can write left right. Okay, so at right, at left oxidation will be occur, at right reduction will be occur. Okay, and it will be left side will be negative. Okay, and right side will be positive. Okay, so like that you can memorize this thing. Okay, because A come first, A, then left right. Okay, then oxidation reduction. Okay, always remember that at cathode what metal is deposited. Okay, that's why it is a known as cathode. And metal deposited means metal, when metal will be deposited, when it convert in solid form. Okay, any M plus will convert in M. Okay, so always reduction will be there at the cathode. Okay. Then represent some common cells by cell notation. Okay, so suppose this is the cell copper plus AgNO3 cell. Okay, so here copper is converting in copper plus to iron. Okay, and reduction Ag plus in converting in Ag. Okay, so here this is the oxidation reaction and this is the reduction reaction. So first of all we will write oxidation reaction. Obviously we know. So first of all we will write oxidation reaction. So copper, then single vertical line, Cu plus 2. Okay, so this is representation of first half cell. You can write here concentration also if you know. Okay, X concentration, so you can write X concentration. Then salt bridge, because these two half cells will connect by salt bridge. Then reduction will be there. So how reduction will be there? Ag in iron convert in metal, so it will be Ag. Okay, it is also connected by single vertical line. Okay, so this is the representation of your complete cell. Okay, so these are the example. By this way you can represent your electrochemical cells. Okay. Okay, then to derive electrode potential, we should know about oxidation potential and reduction potential. Okay, so what is the oxidation potential? When any species oxidize, okay, then how much potential is there? Okay, so the tendency of electrode to lose electron. Okay, so oxidation potential will be measured the tendency of lose electrode by the electrode. Okay, thus oxidation potential give tendency to electrode lose electron. Okay, so zinc is converting in Zn plus 2 electron. So zinc has tendency to lose electron. Okay, so its oxidation potential will be positive. Okay, but suppose we are thinking about the reverse reaction, Zn plus 2 ion converting Zn. Okay, so this reaction is spontaneous. Okay, so oxidation potential is positive. So if we are discussing about this reaction where Zn plus 2 taking 2 electron and converting in Zn plus 2. Okay, so this reaction is spontaneous, Zn plus 2 to Zn plus 2. Okay, Zn to Zn plus 2 is spontaneous. So this reaction will not be spontaneous. Okay, obviously. So the reduction potential of this reaction will be negative. Okay, so any reaction which has positive potential of oxidation, then it will have negative potential of reduction. Okay, it should be clear. Similarly, copper taking 2 electron and converting copper. Okay. So the tendency of electron to gain electron, okay, get reduced is called its reduction. Thus, so suppose we are taking example of silver. Okay, so silver will take electron and convert it Ag metal. Okay, so it has tendency to convert. It is a spontaneous reaction. Okay, so it will be positive. So its reduction potential will be positive, but its reaction will be occur like that. So its oxidation potential will be negative. Okay, so this concept should also clear in your mind. Okay, then electrode potential also depend on the nature of the metal and its ion, concentration of ion in solution. Okay, what electrolyte you are using and what are the concentration, then temperature. Okay, then we will discuss about that. We will discuss about Nernst equation first. Yes, this thing I need to explain you. Okay. So how you will able to identify that which metal will be oxidized and which metal or which element will be reduced? Okay. So to explain this thing, we are going to discuss about electrochemical series. Okay. So this electrochemical series will explain you this. Okay. So in this electrochemical series, 2 hydrogen gaining 2 electron and converting in hydrogen. Yes. Okay. So the potential of this reaction is taken as 0. Okay. Now any element which has more tendency to gain electron, okay, then its potential will be positive, and if any electron has less tendency to gain electron, then its potential will be negative. Okay, so suppose now we are taking suppose zinc. Okay, so zinc plus 2 electron converting in zinc. Okay, so it is not possible. The reverse reaction is possible, but the forward reaction is not possible spontaneously. So you need to provide some electricity, okay, from the outer side. That's why its potential is negative. Okay, and it is reduction. We are talking about the reduction, so it is reduction potential. Okay, so reduction potential of zinc is negative. Similarly, iron, cadmium, nickel. Okay, this is negative. Similarly, suppose copper. Okay, so copper taking 2 electron and converting in copper. So it is a spontaneous reaction. So its potential is positive. Okay. So if you are going to make any cell, you can take one element from this side or one reaction from this side and one half reaction from this side. Okay. So if you are taking 2 reactions from this different section, and this section is divided from the hydrogen. Okay. So if you are taking one reaction from upper side and another reaction from lower side, then you will able to make electrochemical cell. Okay. So it will be spontaneous and you will get some potential. It will depend which element you are taking. Okay. And some factors are also, but this point of view you can understand how electrochemical cell work. Okay. And what is the reduction potential of this thing. Okay. So reduction potential of element which are above the hydrogen is positive, and reduction potential of element which are below the hydrogen is negative. Okay. So this is very important. Okay. For electrochemistry, it is very important to learn about the electrochemical series. Okay. And the position of elements in electrochemical series you can interpret what will the value. Okay, so if you are making the electrochemical cell from the electrochemical series which are just discussed, so how you measure total standard potential? Okay, so it will be E cathode minus E anode. Okay, E cathode minus E anode. Okay, so E cathode means what is happening at the cathode, and what is the reduction potential at cathode, and what is the reduction potential at the anode. Okay, so we will discuss some examples so it will be more clear. Okay, so Nernst equation is already, I think it is explained. Okay, so this is the standard potential as we discussed in previous just now. Okay, this is the standard potential, but your concentration can be vary, your temperature can be vary. Okay, so then your electrode potential also will be vary. Okay, so to find out the electrode potential you need to use Nernst equation. Okay, so this is the electrode potential. Okay, it is standard electrode potential minus RT upon NF in this is the concentration of product, which is this is the concentration of reactant of your half cell. Okay, so here this M plus gaining electron and converting in metal, so it is Ms plus N, but it is Ms solid, so its activity or its concentration will not change. We can take it as unity, so it is only depend on concentration of your metal ion. Okay, so like that you can calculate Nernst equation. Here R is constant. Okay, and temperature is also, if you are taking a room temperature, then it will be constant, otherwise it will be vary. Then F is also constant, it is Faraday. Okay, so if you can put this value, so you will get more convenient equation like that. Okay, so substituting the value of R, which is 8.314, temperature 298, and Faraday it is 96,480, but generally we can take 96,500. Okay, round figure. So if you are putting this value, you will get this all value are we are putting here, so we will get 0.059. Okay, so this equation will become more convenient to use. Okay, so here again this is Ms, so its unity its activity only 1, or concentration we can take 1 only, so it is 1. Then this okay, so temperature mention it is compulsory. Okay, because we take 298 temperature. Okay, room temperature we have already taken, so you need to mention temperature here, because we have already taken 298. If it is not room temperature, then the value will be changed, this value will be changed, 0.059 will be changed. Okay, it will be depend on temperature, because RT upon NF na, and T is already taken constant. But if your reaction is not at room temperature, then you need to calculate again, this value need to calculate again. Okay, so this is all about Nernst equation. Okay, so how we can calculate E cell? Okay, how we can calculate E cell means potential of your cell. Okay, so it is what I discussed, you know, means it is E left, oh sorry, it is you can say E E right minus E left. Okay, So electrode potential at right hand side minus electrode potential at left hand side. Okay, suppose this reaction is happening here again. Let me first I will draw. It is zinc, copper. Okay. So here Zn converting in Zn plus 2, and here Cu plus 2 converting in copper metal. Okay. So first of all we will mention. First of all we need to find out the E right. Okay. So E right means potential at right hand side. So we need to use Nernst equation here. Okay. So what will be Nernst equation? It will be E0 of Cu plus 2 to Cu. Okay. Then minus whatever the quantity is there. Suppose we are taking at room temperature only. Okay. And it is 2 electrons are there. So we can say 0.059 upon 2. Okay. Log. So it will be, equation will be copper, then Cu plus 2. Okay. So this is the Nernst equation of right hand cell, then minus Nernst equation of left hand cell. So it will be, we can write E0 of what? Zn plus 2 to Zn minus 0.059. Here also it will be 2 log Zn plus 2. Okay. So now if you know the concentration of all this copper and zinc, then if you will put, and you will finally able to find out E cell. Okay. So by this way you can find out that the cell which is made by zinc and copper electrode, zinc as a anode and copper as cathode electrode, and what concentration you took for making this cell, and what are the temperature you are using, and on the basis of that what is the what is the potential of your electrochemical cell. Okay. So by putting your value in Nernst equation, you can finally calculate this equation. Okay. Okay. So this is all about this. Just a minute. I need to discuss one more thing. Okay. So now why we are discussing about the electrochemical cell? Because we can use electrochemistry in our analytical chemistry also. Okay. So by using electrochemical cell, we can measure potential, current and charge, and according to this quantity or this values, we can quantify our analyte. Okay. We can quantify our analyte, and on the basis of this quantification and we can qualify also and quantify also our analyte, and this you can say this thing can be used for analysis of your analyte. Okay. So there are different type of electroanalytical techniques, which are potentiometry, voltammetry and colorimetry. So potentiometry, you will be able to measure voltage. Okay. Voltammetry means you will measure voltage and current, and here you will only measure current. Okay. So we will discuss detail. We will discuss this thing in detail also. Okay. So here you can say it is a sensing electrode. Okay. One will be reference electrode. This is the reference electrode, and another is sensing electrode. And suppose this is your analyte. Okay. So when you are passing some current will be passed, and according to property of analyte, the signal, which are voltage, current, okay, will be changed, and on the basis of that you can measure the property of analyte. Okay. So this thing can be used for your electroanalytical chemistry. Okay. So these are different type of electrode. Okay, metallic indicator electrode. So this can be three type: first, second, and redox electrode. So in first type, electrode of the first kind, a metallic electrode whose potential is function of concentration of M plus. Okay, so suppose you are taking M as an electrode, so its potential will be generated at this electrode will be function of the concentration. Okay, so more concentration you will able to find more current. Okay, so you can correlate according to your analyte. Second type is electrode of the second kind is a metallic electrode whose potential is function of concentration of X in the Mx. Okay, X is some species in your analyte. Okay, so here it is only metal only, same metal, but here it is different species, which is function of this. So what we say, electrode whose potential. Okay, so potential is function of concentration of this species X. Okay, so as concentration of this species will be increased, okay, it will be influence the potential of the electrode. Okay, and finally the third type of electrode, redox electrode, an inert electrode. Okay, so this electrode is inert, that serves as source of sink for electron for redox half reaction. Okay, so whatever reaction is occurring in your electrolyte, okay, so it will be work as a sink. Okay, so it is in an inert electrode, but it serves as a sink for the electrode, or it can work as a sink, and it can work as a source. Okay, for the redox half reaction. Okay, what are the redox reactions are occurring? It can be occur as sink or source. Okay, so this is all about this week. Okay, if you have any question you can ask, otherwise we will stop here and we will meet in next week. Okay, any doubt? Saraswati? Yes. Second kind, calomel, just a minute. Yeah, so electrode second kind, the calomel electrode means what? Just a minute. Just a minute. Okay, you are telling about that. Okay, so means a metallic electrode whose potential is function of concentration of X. Yes, it will be like that. Okay, because in your analyte, suppose it is KCl. Okay, so its potential will be different, will be depend on the Cl only. Okay, so it will be depend on the concentration of chloride ion of your analyte. Okay, so it will be depend on this thing. Okay, yes, you are right. So it will be second type of electrode, calomel electrode. Yes. Okay. So any another doubt? Any other doubt? Okay. So we should stop here and we will discuss. We will meet in next. We will meet next week with the week 10 assignment and concepts. Okay. Okay. Okay, Dilsan, 3000, any doubt? No? Good.